Hello everyone, I am Bradley Sward, and this is my Day 11 solution to the 2024 Advent of Code problem, otherwise known as Plutonian Pebbles. I'm solving it today, as I almost always do, in Python. And so the problem is called Plutonian Pebbles, and basically you have a list of numbers, and then you're going to be manipulating the numbers round by round, or they call them blinks in this case, so blink to blink. So if I started around with this list of numbers, 0, 1, 10, 99, 999, because it's a 0, rule 1, if it's a 0, turn it into a 1. Otherwise, if it's an even number of digits long, not counting leading zeros, in this case it's not, so if it's not, we're going to multiply it by 2024, and then we get that. In this case, it's an even number, so I'm going to take this, I'm going to cut it down the middle and use this and say, okay, take this as a 1, and create a 1 and then create a 0, and then you have to eliminate any leading zeros. That's we can just integer, in Python we can just use integer and it'll do all the parsing for us. But that's pretty much it here. Like, if you have an even number of digits, you cut it in half into two separate stones. Otherwise, you multiply by 2024. And for step 1, it's pretty easy, but then for step 2, that's where things take the step up. And if you're not using the right data structures, who knows how long it'll take you to solve this issue, this problem that we have. I don't even know if you'll have enough RAM for it. I forgot to look at the number. I don't even think you'd have enough RAM in your machine if you didn't have the correct answer. So my code is as follows here. So for step 1, I think I did what most people, I knew something was coming, but they threw into there when they were talking about it, which threw me off. The order is preserved. Well, it doesn't frickin' matter. It has the order has, at least in the way we're solving our problems, the order in which we have these things stored means absolutely nothing to us. And so we can get rid of that whole line, and that would have sped things up for me anyway. But just to say, coming back again, so I'm keeping track of a map, and I'm keeping track of values, of which values are in the map, and then the what numbers are in my group of items, and then the values are, well, how many times have I seen them, or how many times are they there? Because the problem becomes, if I have like 100 zeros in my list, I'm going to process that 100 times. Well, I only want to process that one time because there's 100 zeros that need to be turned into 100 ones. So I can exponentially and then some speed up my algorithm by just accounting for, if there's 100 of them, we'll do the operation once. And that's why a vector doesn't work here. It might work for part 1, but then for part 2 I was running it and I'm like, oh no, it would just take, I mean, if I had the RAM, it would take days at the very least, exponential, who knows? I mean, it could take years, and then and then how many years? But anyway, so what do you do here? I start with my list, and then I'm putting it into my initial map structure. So I can see here, when I get to the initial map here, if I pop it here, I get my stones, and I go, well, there's a 1 in there, there's 127, there's 110,640, there's 103, and it just goes off my data. And of course, it's all in semi-random but semi-sorted order here when it comes to the way that the map, the dictionary, stores its data. But then for 75 generations, I'm doing exactly what I told you. I'm just saying, okay, I'll keep track of the time, how many times I'm going to be adding something to the map, and then if it's a 0, add a 1. If it's an even number of digits, split the thing in half string-wise, and then add the values there into the map, and otherwise multiply it by 2024. And again, the key here is you have to just check to see if the value is already in the map, well then add to it, otherwise if it's not, set it. And that's the only real big difference here. And then when you run this, you run the code, you get the solutions 229,043 for part 1. So part 1, 229,043, and then this, yeah, there's no way, how much, boom, 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 millions, billions. We're in the 272 trillions if I did the math right. Nobody has 272 trillion items they can store in a vector. Maybe one day, but not today. So without a good data structure, this is unsolvable. And this is a pretty decent one. It could probably be very much improved here as well, but I got my solution. I'm ready to move on to day 12. So that was fun. Hope you had fun too doing the problem. Hope you enjoyed it. Hope this helped any of you watching. As always, comment if you feel the need. Thanks for watching. Catch you guys later.